Hello everyone and welcome back to our numerical methods series. In today's video, we will dive into one of the most practical and visually intuitive techniques used to find the roots of a nonlinear equation, that is a secant method. So whether you are just a student, an engineer, or just curious about numerical techniques, this method will sharpen your understanding of iterative root finding algorithms. So stay tuned because we will also break down the graphical representation for a clearer conceptual grasp. So we have to construct a graph. Okay, so this is our y-axis and this is our x-axis and this is our graph. And here we have point P naught and here we have point P1. At this point, the graph touches x-axis and this is basically the root of the equation and we need to target that. Okay. So the secant method is an iterative numerical technique that is used to find the root of nonlinear equation and we just call it y is equals to f of x that is equals to 0. So unlike the Newton-Raphson method which uses the derivative, the secant method just approximates the derivative using two previous points on the curve. Now let's take a look at this graph. We start with two initial guesses, that is P0 and P1, that is located on the x-axis. These are the points where we evaluate the function f of x, giving us the corresponding function values f of P0 and f of P1. Using these 2 points, we draw a secant line, a straight line that connecting this P0 to P1. So this means that we have 2 points P0, f of P0 and P1, f of P1. So this line is then extended to intersect the x-axis and the x-intercept of this secant line becomes our next approximate and we call it P2. And this is how we iteratively generate new points. So the generic formula used for secant method is Pn plus 1 that is equals to Pn minus 1 f of Pn minus Pn f of Pn minus 1 divided by f of Pn minus f of Pn minus 1. So we then repeat the same process and draw a new secant line between P1 and P2. So here we have a P2 and we just connect P1 to P2 again like this. And this is our new approximate root and we call it P3. So by drawing this, we will get a new point P1, f of P1 and P2, f of P2. So find its x-intercept which becomes P3. Continue iterating, we will get P4, P5 and so on. If we draw another one, so we connect P1 with P3 just like this. So we get a new approximate root and we call it a P4. If we target out again, so we just connect this line with this point, and we got another approximate route, that is P5, and so on. So in this diagram, you can see that the points gradually converging forward towards the actual root of the function. So each new secant line gets closer and closer to the x-axis where f of x is equals to 0. So this visualization makes it clear that how the secant method works without needing a derivative. So the points that we take away from this graph is number one, secant line approximate tangents. So secant line approximate tangents without needing any calculus. Secondly, this method requires only a function value, and not its derivative. Thirdly, it converges faster than bisection. Faster than bisection method, but usually slower than Newton-Raphson method. And the last one is, if the guesses are good, it leads to quick convergence. So we just simply write it. Guesses are good, it leads to quick convergence. So if the guesses are good, it leads to quick convergence as shown by P2, P3, P4, P5 that approaching to the root. So to wrap up, the secant method is a beautiful blend of a geometry and algebra, relying only on two guesses and the shape of the function to locate a root. Graphically, it's intuitive, just draw secant line and watch them steer you to the solution. So if you enjoyed this graphical walkthrough, give this video a thumbs up, subscribe and share it with your classmates or friends that is studying numerical methods or numerical analysis and computation course. Have any questions? Drop in the comment below. I would love to hear from you. So thank you so much for tuning in. I'll see you soon in the next video. Stay blessed.